Welcome to the fourth video of the series we're doing on standard categorical syllogisms within critical thinking. In this video, we're going to save you at least a pound of the LSAT practice problems. And in particular, what we're going to learn in this video is the rules and the system for evaluating these syllogisms. So far, what we've learned in categorical logic is the statements, and now we're ready to add those up into arguments. So a categorical syllogism is three standard form statements where there's two premises and one conclusion. None of this is surprising. In fact, you'll see that we've actually occasionally use these as counterexamples or as examples in the class so far. So I'm hoping that we're a little bit comfortable with these. But an obvious question can be, well, lots of arguments are really long and complicated. And so how is that going to work when you're telling me that these are exactly three standard form statements? And the answer to that is that imagine that we could create chains where the conclusion of one argument then becomes a premise of another, and we can either build a pyramid or a chain of arguments such that each premise is justified by a prior argument. And the fancy logic word for that is a seriades, which is just a Greek word for heap. Okay, so there's a pile of arguments can be combined. So the standard categorical syllogism has these features. Has exactly two premises and one conclusion. Each of the premises and the conclusion is a proposition expressed in one of the four standard forms, A, E, I, or O. So that's why we spent like 3 videos learning how to get those things. And exactly 3 terms, each of which occurs twice. Remember that in each A, E, I, or O statement, there are 2 terms, a subject or a predicate. And so when you have 3 terms on 3 statements, each has to occur twice. We're going to give these terms names according to where in the argument they occur. So we call them, within the context of a statement, they're subject and predicate. Within the context of an argument, then those same things become either the minor, the major, or the middle terms, depending on where they are. And let me explain what I mean by that. The minor term is one which occurs as the subject of the conclusion. It also occurs, because remember they all have to occur twice, so it also occurs as a subject or a predicate in one of the premises. And then the premise that has the minor term is called the minor premise. The major term is the one that occurs as the predicate of the conclusion. And it'll also appear first as a subject or a predicate in a premise. And so then it'll be the premise that contains the major term is the major premise. And then we have 3 terms. We've named 2. The third one is the middle, and it'll occur in each premise, not in the conclusion. And we call that the middle term. It's connecting the argument together in the middle. We have minor, major, middle. So let's look at some examples just to see how this works, okay? So when you look at an example, you want to say, first, look at the conclusion. So no cats, the minor term is the subject of the conclusion, and mammals is the major term, the predicate of the conclusion. Okay, and now we work backwards and say, well, there's mammals there, so that's still the major term, and this statement becomes the major premise. Cats occurs in the first premise, and so that's the minor premise. And then notice that dogs is left over. It's neither here nor there, so it is the middle term. Notice, however, that it's also acceptable to have the minor. So remember our definition. Let's back up a step in here. Okay, this is important to get this right. Okay, both the minor and the major are in the conclusion, and you know that for instance, the major, you know it's the predicate of the conclusion, but it could be the subject or predicate in the premise. So here we have. Notice that cats was subject in both its conclusion and premise instance, and mammals was a predicate in both its conclusion and its premise instance. Here we have fruits, subject in the conclusion, but a predicate in the premise. Perfectly acceptable. And likewise, a round is a predicate in the conclusion, and it's a predicate in the premise. And then the middle term is a subject in both cases it occurs. Okay, so the middle term and these premise terms, they can roam around a little bit. All you know for sure is that they cannot be in the same premise. Each of the subject and predicate of the conclusion have to be in different premises, but they can be anywhere in their premise. So now that we've got that terminology, we've got some options for making these, assessing these arguments. Now, the most traditional, historically the most long practiced form is to actually memorize all 256 possible forms, and especially the 24 that are known to be valid. So you would say, oh, I recognize this form, and I recognize this form, and I know whether they're valid or invalid just by their structure. And every year I've offered my students an opportunity to use that system. You only have to memorize 256 possible things. How hard could that be? No one's ever taken me up on that. And maybe this is not the year to try it either. Instead, we could memorize 6 things. We're going to learn 6 rules. Now, that's 250 less. I think there's some merit in that. We're also going to learn and apply a simple Venn diagram method, and that'll be the subject of the next video. We're going to do the rules today. I think I'd like to just tell you a little bit about how the 256 syllogism system works, where each form had a name. And what's cool is the vowels of the name told you the form. So if you have a syllogism named Barbara, notice that all the vowels are A. And so when you look at the form of the argument, you go, oh, this is A form, A form, A form. And that, in fact, is known to be a valid argument. Then we could have a syllogism called Clementi. EEI, which is EEI. And so we have no cats are dogs, no dogs are fish, therefore some cats are fish. It doesn't look like a very good argument. So you might think, okay, Clementi, not valid, Barbara, valid. Okay, so if you're going to sit down to memorize 256 things, it's good to have a plan, and there is a plan available to do that. And in fact, what the ancients would have done is define the form and then attempt to come up with a counterexample. And if they did not come up with a counterexample, then they would, after lots and lots of work, say, well, it probably is an okay argument. The rules for validity are much newer historically, and that's great. So basically, we're going to work with the traditional interpretation. People often think of this as the Aristotelian way, where there's 5 rules, and that system doesn't allow there to be empty sets. If you have empty sets, you need one extra rule. So I'm going to teach you the 5, and then we'll add the 6. And then we'll realize that there are going to be some. Remember I told you there's 24 valid under the 5 rules, the traditional method. We go down to 15 possible valid arguments if you use the modern interpretation. Okay, with all that being said, let's learn the damn rules. First rule, syllogism must have exactly 3 terms, each occurring twice. So really this is, you might think of this as the syllogism must be well formed, right? You have to actually have a proper syllogism, because this was actually in the definition of a syllogism. Let's be nuanced here, though, and realize that this has to be more than just looking like it's the same term. It actually has to be the same. And when we get to interpreting ordinary language arguments, we'll realize that, well, is it the same or do they mean something different? There's going to be some subtlety to that. But this middle term being exactly the same is how those two premises kind of lock into each other, and you don't have that sort of random element that was so characteristic of the fallacies of relevance, right? And if you don't have this, typically what you have, in fact, is instead of 3 terms, you have 4 terms, and we call that the 4-term fallacy. We, in fact, saw this when we did the counterexample on equivocation. Once we realized that nothing means something different here than here, so here we're talking about no food is better than steak, and here we mean spam is better than going without. Then we realize actually what we got there is 4 terms. And so we would realize that there's a bit of a clever mapping between the informal fallacies that we kind of recognize by, it looks kind of fishy. We now have a much more clearly defined way of telling whether something's a good argument or a bad argument. Second rule, middle term must be distributed at least once. Remember last video we spent some time thinking about whether a term is referred to by the statements in, and there was a point to that. The point is this is going to really help us figure out if a syllogism is good or not. And if an argument doesn't have this rule satisfied, then what you have is the fallacy of the undistributed middle. Okay, middle term distributed at least once. So let's look at an example. All dogs are mammals, all cats are mammals. Both of those statements are true, but it's not the case that all dogs are cats. Not even that one. And what's happening, of course, here is that this statement refers to every dog, but only some mammals. This statement refers to every cat, but only some mammals. When you refer to that middle term only some both times, you have no guarantee that the mammals you're talking about in this statement are the same mammals you're talking about in this statement. And so you don't have that tie together that typically makes a good argument. Rule 3, a term distributed in the conclusion must also be distributed in the premise in which it occurs. Okay, lots of words there. Let's back up. A term distributed, remember, so that's either a subject or a predicate of a statement. If it's in the conclusion where it is distributed, then it must also be distributed in the premise in which it occurs. So if you have it, whether it be the subject or the predicate of the bottom, the conclusion, then you got to look upstairs in the premises to see, is it also distributed there? You can't talk about some in the premise and then talk about all in the conclusion. Sounds a lot like a hasty generalization, right? To go from some to all. That's exactly what we are trying to cover off here. And depending on which term is not properly distributed, we either talk about the illicit major or the illicit minor. Illicit minor is not sneaking your underage friend into the bar. It is, in fact, a logical fallacy. So, and the technical name is illicit process of the major term or illicit process of the minor term, but that's a lot of words. So we're just going to say illicit major or illicit minor. Let's look at an example. All conservatives are wealthy. All wealthy people are wise. Therefore, all wise people are conservatives. So let's think about the distributions here, starting in the conclusion. The subject is all wise people. So that's clearly distributed. Conservatives, the predicate of an A form statement is not distributed. So we got to check the wise. All wise people distributed here. The predicate of a form here. So wise, we're only talking about some wise people here, but we're talking about all wise people there. So that is a illicit minor. The minor term, the subject of the conclusion, is not properly distributed where it occurs in the premise. And if you're looking for a counterexample, there's Tommy Douglas, a wise non-conservative, and I guess I could probably swap out Sarah Palin for Donald Trump here to have an unwise conservative. There's Sarah Palin checking for the writing on her hand to remember what city she was in. Rule 4, you can't have two negative premises. And if you break that rule, we call that the fallacy of exclusive premises. Here as an example, no cats are dogs, no felines are dogs, therefore no cats are felines. True premises leading to a false conclusion. Another counterexample, no alligators are furry, some mammals are not furry. Okay, so notice that the not is in the middle here, but it's still a negative statement. And then we're going, some alligators are mammals. So this example has that double negative that makes it invalid. Rule 5. If either premise is negative, the conclusion must be negative. And if you break that rule, then you're committing the fallacy of drawing an affirmative conclusion from a negative premise. And looking at the example, no cats are dogs, all dogs are furry. Oh, sorry, this is satisfying the rule. Okay, you've got at least one negative premise. You have to have a negative conclusion to satisfy the rule. Bit of a weird argument, but I think it's okay. Here's the counterexample. Some annoying dogs are small. I think that's true. Some large dogs are not annoying dogs. Also true. And there's our negative. Some large dogs are small dogs. I think is pretty obviously false. Okay? But this argument, what makes it invalid is having an unmatched negative in the premise that's not matched by a negative in the conclusion. Notice if it was some large dogs are not small dogs, that'd be pretty obviously true. There's a bit of a shortcut available to you. The way these rules are typically given follows copy. You'll find the odd textbook that combines rules 4 and 5 into one. Where and this is typically, you'll see me when we start to do problems. This is often how I think of them. the number of negative premises must equal the number of negative conclusions. So let's think that through. How many conclusions can you have? At most one. So if you've got two negative premises, you're automatically invalid because you can't have two negative conclusions. If you've got one negative premise, then you need a negative conclusion. If you have zero negative premises, you can have zero negative conclusions. So when I'm doing these, I'm trying to make some progress in a hurry. I'll count the negatives and see if I got a match. If I don't, then I got to dig a little deeper to find out what specific fallacy is being committed. If it does match, I just move on. And that is the 5 rules that this logical system worked with for most of its history. And now we're going to look at the rule 6 and why there is a rule 6, first of all. So, we've talked about this a little bit already, but we'll have to talk about it some more. Remember that some we're defining as at least one. Let's look at a set within a syllogism that we think is empty. I'm pretty doubtful that unicorns exist. Okay, so at the same time, I agree, unicorns have horns. It's quite frankly right in their name, right? What is a unicorn? It's a horse with a horn on its head. Okay, so I think that's true. All horned creatures are dangerous. Well, they'll poke you. So I think that's true. Therefore, and this argument does not break any of the rules. Some unicorns are dangerous. Let's check. Okay, so we got to think of our rules. Do we have 3 terms each occurring twice? That's rule 1. So we got unicorns twice, horned things twice, dangerous things twice. Rule 1, check. Rule 2, is the middle term distributed at least once? Well, the middle term is the one that's not in the conclusion, so that's this horned business, okay? And in the second premise, it's all horned creatures, so that would be distributed. Check. Rule 3, terms in the conclusion must be distributed in the premise in which they occur. Well, the premise or the conclusion is a I-form statement, so it's neither distributed in unicorn or in dangerous. So we kind of pass that by default. If it's not distributed here, it doesn't have to be distributed here. Well, if it's not distributed here, anything goes in the premise. So rule 4, I can't have 2 negative premises. We do not. We have 0. Rule 5, you have to have a negative conclusion if you have a negative premise, and we don't. So we pass rule 5. So according to the historical system, that's a valid argument. That would be one of the 24 that's counted as being valid. But isn't this weird that it's saying there is at least one unicorn that is dangerous, right? Our interpretation of some is tripping us up here. And so we think, oh boy, I've got some worries about that argument. And so and here's historically a very important argument in philosophy. This is my version of it, but there's lots of different versions. In general, these are called ontological arguments. These are arguments that rely on sort of definition rather than evidence to argue for the existence of God. So we're getting a borderline into philosophy here, but I think it's interesting. Okay? So, all gods are things that care about everyone. Well, I think lots of religions would buy that. All things that care about everyone are things that care about me. Well, since I'm part of everyone, that seems also true. And therefore, here comes the conclusion to the syllogism. Some gods are things that care about me. And that argument passes the 5 rules. And for much of the history of philosophy, people said, aha, there you go, proven it, God exists. because the interpretation of some is at least one God exists. Now, our problem is that's exactly like the unicorn example. If we're not so sure about unicorns, why are we so happy about the gods? And so, people thought about this pretty carefully. And ultimately, we realized that Rule 6 is required. A particular conclusion requires at least one particular premise. And if you don't have that satisfied, you have what's called the existential fallacy. You're making a mistake about the existence of something. And when you apply this rule, you go down from 24 valid syllogisms to 15. And, I'll comment on this a little bit more. Remember we talked about the fallacy, which is it's a mistake to infer that because an argument makes a fallacy, that the conclusion is false. I would say that's very much the case here. This argument commits the existential fallacy. That does not in itself constitute proof of the sort of the contrary, or in this case, the subcontrary of the conclusion. Okay, so what do we know about the existence of God based on this argument committing the existential fallacy? Nothing. Neither for nor against. Try again, right? Now, for the field of theology, recognizing that this argument didn't cut the water people thought it did for thousands of years was probably not a pleasant thing to do. But I would very much strongly take the position that the fact that we now understand that this argument commits a fallacy does not make us think this argument's conclusion is false. Okay, very important logical concept there. Don't go from that's a fallacy to that's false. If it's a good argument, that's good. But if it's a bad argument, that doesn't mean the conclusion's false. Once we got the rules, we can put the argument into form. So, because let's face it, the arguments we're going to want to assess are not going to be cats and dogs. They're going to be ordinary language. And so we're going to have to first translate it. We did that in video 1 into standard form. Then we got to find these minor, major, middle terms. Then we got to identify the distribution of the terms. Once we've done that, then we can check our rules. And here's a quick summary, as briefly as possible, of the rules. Depending on the textbook you're using, the number might be slightly different. It's not unusual for this first rule, which is kind of just a definition of syllogisms, to not be given as a rule. Lots of textbooks, including the ones I've chosen, will put it in the rule because what I want to see is for every rule there is an associated fallacy. And since there is a 4-term fallacy, we better remember that there's a rule about that. So that's my thinking here. So don't get hung up on the numbers of the rules. So you could have as few as, so remember you could also combine 4 and 5 in the one rule. So if you leave that as a definition, then you have 1, 2, 3, 4 possible rules. So you might find a textbook that has gives these as only 4. I think 6 is fairly standard. I'd be curious to hear from you what textbook you have and whether it conforms, what system it conforms to. But don't panic if it's not exactly 6. So that's it for the rules for categorical syllogisms. Next video, we're going to do the Venn diagrams. And then, and I apologize, I've kind of really burned through this fairly quickly. My goal is to get all the definitions loaded into your heads, and then we're going to do problems. But let me demonstrate what we've got so far. So we're going to spend lots of time doing problems. We're going to do one whole video on just looking at syllogisms in ordinary language and getting them into form and then assessing them, which is really for the purposes of critical thinking. If it's all just abstract logic, pointless. We want to learn how to apply this to ordinary everyday situations. So here, as an example, suppose you have the argument, some wasps must be bees because all bees are yellow and some wasps are yellow. Okay, first thing to do, what's the conclusion? We got to figure out what this argument is trying to do. Okay, so we've got a logic indicator word here, because that tells us reasons are coming, right? We did all this when we did fallacies. And we've got this word and. The and is typically a giveaway that it's joining two things of relatively equal role in an argument. So if you have because, here comes a reason, here's one reason, and here's a second reason. So we've got premise, premise, conclusion. Okay, so now we got it in form. All bees are yellow, some wasps are yellow, therefore some wasps are bees. We might want to then say, what's the form of these statements? The first one is universal and affirmative, right? So it's not negative. So we have all bees are yellow. That seems like an A form statement. Some wasps are yellow is an I form statement. And then some wasps are bees is an I form statement. Now, once we know the statement forms, we know the distributions. It would be all bees distributed are yellow undistributed. Some wasps undistributed are yellow undistributed. Some wasps undistributed are bees undistributed. And then we check our rules. Do we have three terms each occurring twice? Bees twice, yellow twice, wasp twice. Check. Rule 2. Middle term must be distributed at least once. Wait a minute. We have all bees yellow undistributed. Some wasps are yellow undistributed. So this argument breaks rule number 2, fallacy of undistributed middle. Would there be any point in checking the rest of the rules? Not really. Like it's invalid. It's invalid. That's it. Now, if you're practicing these, it might be interesting to also check. So we'll do it, but this is for practice. We're not going to learn anything more about the argument. We might learn something more about the concepts. So, rule 3. The terms distributed in the conclusion. Now, nothing is distributed in the conclusion, so we pass that rule by default. Rules 4 and 5 are about the negatives, and there's nothing negative here, so it passes that. Rule 6, if there's a particular conclusion, so something that starts with some in the conclusion, you need at least one premise that starts with some, and so it satisfies that rule. So this example breaks exactly one rule and commits exactly one fallacy. You can for sure have, I've never seen an example that breaks every rule. I rather suspect that's not possible, but boy, you can get pretty close. You can get 4 fallacies in one argument pretty easy. So that's what we're going for in the end. And once we get the Venn diagram material learned next video, then we'll do one more video, which is nothing but just working through arguments from ordinary language into syllogism form, and then checking the rules, checking the Venn diagrams, to coming up with a counterexample. And and then we're ready for the test. Thank you very much. Have a great day.